We should be live now. We are live. Very, very live. Very, 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 very live. All the lives. Oh, right. Steam. I need substance. I forgot that I did not have it installed. I have Substance 2022. Yeah, I got the old terms. Sweet. Here we go. All right. So, what we're going to try and do now is if we come into here, we have this. I still want to know why this is see-through. Specifically, why is this see-through like this? Here comes the fives. What up? What's up, man? Give me one sec. I gotta close something on my other screen here. How are the things? Yeah, I'm fine. I'm doing awesome vibes, and you? I'm doing pretty decent. Today I found out that it was a holiday when I went to go to my morning meeting, and it was canceled due to holiday. So, definitely a nice to see, nice to have. I want to know why am I invisible here? Like why are these not painted correctly? It's bothering me because I don't think they're UV'd either. Mm. Okay, so I'm gonna try something and see if this works. Yeah. Okay, so if we go to face, we grab this, we delete it, we do edge. I want to see if this is actually the problem. I don't think it is. Also, it's something that I don't think that I'd want to fix because way too much work. I think it's still going to be a problem, right? Okay. We go like this and then edit. Export selected. I hate how tiny this UI is. I gotta say. Yeah, they definitely do. I would say something, but there's not actually a person on the other side. Hmm. Houdini, some of my faces are... Hmm. Geometry shades. I wonder... wonder if it has anything to do with, like... I don't know. Kind of weird. Okay, so we can split this up and then we can merge stuff together. I think that I need to probably do that. Um, let's actually do that here. I'm kind of debating here because, like, I could merge these two pieces together and it would kind of make sense, but, like, at the same time, it kind of doesn't. It's such a difficult decision. They are separate pieces. Let's keep them separate. Yeah, okay. We're going to keep them separate. So kind of the nice thing is that this does come through correctly in my front, like in the game, in engine. It actually comes through just fine. So kind of happy about that. But let's just add it. We don't actually need to UV unwrap this. We can just not worry about it. Okay. Now for the source of truth here. What we're going to do is we're going to see if we can figure out a way to replace the existing piece, which is this one here. This here, we're going to see if we can replace this with the piece that we just made. Houdini OSM replace buildings with...
You can see here. And what I will be doing is using the labs building generator to generate my buildings. So before I will do this, to save some time, I will also cut out a piece of the map. So right now, if I would plug in the building generator, we will need to calculate all the buildings I see here on my screen. So to make everything a bit go faster, in here, I want to cut out some parts. So I will be using a clip note. So as you can see here, placing down a clip note, we'll then have the option to then cut out different parts of my scene. And as you can see now, I only have a few buildings. So what I want to do here on these buildings is use a for each connected piece. So this means I will loop over each building individually. So in this case, I have 26 buildings. I will loop over them individually. So in here, let's just start with one building and plug this in the building generator. And you can see that by default, it will generate all this geometry. Now we also have some settings here. So first of all, like the floor height. So if I would go back here to my OCM buildings, we have set the level height to 4. So we can do this here as well. So we can set it to 4. So we have new levels. Now further, we also have here some primary and secondary options. So primary is for our main wall, secondary is for top ledge and bottom edge. So you can enable and disable this. So now the bottom edges are gone, but we can also disable the top edges. So but in this case, I'm only using the top edge, so I actually want to enable this back. And now I want to, instead of having this plain geometry, I want to have a custom model. So therefore we need the other node called the building generator utility tools. And in here I can then have a file node for my geometry. So in here I will look up my FBX file and load in my file. So load in my file and let's plug this in. So now I need to give this a proper name. We can just call it, for example, wall 01. Then we also need to fill in the dimensions of this wall.
This isn't quite what I was looking for. It's good, but it's not quite what I was looking for. I don't want to generate it. I want to place a building. Ugh. Ooh. Houdini match. Sorry. Houdini. Copy. Copy rotation. Copy object rotation with mesh. No, it's kind of hard. I could do this. And then if I come down to here. No, this one. And then we want this. There we go. I'm 100% sure there's a way to do this that's more correct. But we can do that. And we're pretty well perfect anyways. Sorry. The only issue is that this is not maintainable long term. Oops. What this? Right, we need to then copy it to this location. There it is. We got the first one in. I've got to find a better way to do this. I'm going to probably ask my buddy for a better way. But I need to take a quick look at the map and see if this is oriented the right way. No, no, no. There we go. I think it is because I think that's the one. That is the one right there. It's rotated wrong. Okay, wait. It's that and this and then that. I don't think that's it. No, that was it. Okay. Sweet. We got it. Yeah, that's this section here. So that's a walkway for not vehicles, I don't believe. Oh no, vehicles can come down here? I didn't even realize that. Interesting. Okay, sorry. Sweet. Swigon. 20 months. Oh, sup, Polybits. 20 frickin' months in a row. God damn, boy. So long. Hey, I know that you're not doing it anymore, but is there a way to copy the rotation of this to this without doing it by hand? So this outlined one, right? I want to just copy, match the rotation. Now, the issue is that I don't think this actually has a rotation itself. Sup, Jack? Because if I like take a look at this, right, we've got the points, but like it doesn't have really an idea of a rotation, so we'd have to create a rotation, right? So I'm not sure that it can really be done. I don't know. Anyways, I figured I would just bring this in here and just do it by hand for in the meantime. Got a meeting with my buddy tonight, and I'm probably gonna ask him, and he's probably gonna be like, "I don't think it'd be more work than it's worth." Is probably what it's gonna come down to. Okay, we come into here. We're gonna hit play. At some point, I've gotta update it so instead of having multiple like instead of it being one giant mesh as the entirety of the city, I want it to be a bunch of small meshes and then be instanced. But I've got to do that inside of Houdini somehow. This is an early stream thanks to the holiday today. Today's a holiday. For some reason, it made me think of Japan. To be fair, this is Japan that I'm working on right now. Why is this not building? What? Did I save it wrong? Uh, uh, what? Okay, that is definitely not what is supposed to be going on. What's up, Caitlin? Like, maybe a little bit, yeah. I definitely see the resemblance. This gives me Untitled Goose Game vibes.
And full of
This looks cute as hell, though. Okay, why is the buildings not showing up? Mm. Okie dokie. Why is the rum gone? The rum's not gone. The rum is quite literally behind me. Oh, you know what? It might be that. Wait, no, because it doesn't matter. We've already generated things. What if we just do a quick clean here? Instead of doing the clean there, what if we do the clean down here? Actually, we could do it here and then also here. And then here we don't have anything, right? Ugh. We need extras, apparently. Look at all of that. All of this needs to be deleted. Oh, that's rename. This is what we want. We want group type of primitives, and we want the star. Oh well. Ugh. Ooh, I know. If I do this, removes everything, and all we want to do is copy attribute copy, right? And then if we come up here, we can do this. We put this one here and this one here. And then there we go. And all we wanted to do is copy the color. And then we can move this here into here. And then we have that worked out. Shop. We have UVs. Where are the UVs? Hey, sup? How's your project going? Slow and steady. My output decided to stop on me all of a sudden. So that's super happy, good fun times. I wonder if it has to do with this file though. Wait, I don't think there was any points, no. Oh wait, no, there was. Yeah, we can just do that. And then if we come into here, this is the primitives. And then I think we've got vertex stuff. Yeah, we do. We can just delete. There we go. And then when we come down here, everything is good. Actually, that might actually fix the... That does. Oh, okay. There we go. I'm adding this to the city. Or at least trying to. But when I go to come down here and I save and then asset, save asset, right? Then I come into here and I rebuild and my city's gone. I don't know why it's gone, but it's gone. So my city just will not come back in for some reason. There's no error that it's telling me about or anything like that. It's just like, hey, this city, it's a no-go. No errors though. If I go like this, don't save. Oh, I was right. Failed to load. Can't find file. Okay. It was exactly that. Okay, so it was exactly the problem that I thought it was going to be. Always nice. Mm. I think we can do a delete attribute. And then we go here to here. And then we go like this. And then we click this, and then we go over to the geometry here, and we say details. We want star, primitives. We want star. And points, we also want star. And I don't think we've really got anything here other than n. Those are normals. We'll leave the normals. Normal. Heard front and what? Is the color. There's my copy attribute. Interesting. Apparently there's a group that needs to be deleted now. Anyways, there it is. And then we've added this effectively. And then we just need to get this in. At the moment, they are still in, yes. What's your game about? Oh. Let me show you. Let's see if it works though. I'm gonna have to change a little bit of like how I'm actually doing things. So we're gonna have to eventually do some programming, I think, to get the placement of buildings. But yeah, it's fine. So this is the building. This is the city. We have full controller support. Let me get it plugged in and it recognizing quickly. There we go. This brown one here is actually the thing that we've been editing. It's gonna be purple apparently now. I think it's that one. Yeah, it's this one here. This brown one is what we're trying to add, and then I've also got to add it for these ones here, like that one and that one that they just passed, and then this purple one right here, and this here is another one. And then this here is another one. Why are there so many pink-haired girls? Because I only really have one model. I have a second model now, but neither this pink-haired girl I don't think is going to end up in the final product. They're just here as placeholders. Because it's the closest thing that I could find to the style that would be easy for me to get in. Because Epic doesn't, like the Unreal Marketplace really doesn't have a whole lot of anime style characters that are city focused. They're all like, the ones that it does have are very not like they're very, fuck, what would be the right way of putting this? They're very medieval-y fantasy kind of thing, and this does take place in a city. Though I do plan on changing some things, so I could probably work around it. But the idea is that you drive around this city, which is right now this city is entirely a representation of Shibuya and the Shibuya crossing in Japan. And you have a set number of targets that you need to go and run over to isekai them into another world to save that world from the Demon Lord. So the schoolgirls right now, the ones in the schoolgirl uniform right now are the targets. The ones in the, I think it's a gym uniform, they are pedestrians, and you're not supposed to run them over. But because they're all the same pink-haired girl base, it can be difficult to pick out the targets right now. So if I actually manage to run over the last 18 of these, I get a nice little message. Give me a second here. Boom. Now, obviously, they're not going to be as tightly packed like this, but right now it's just, this is essentially just, for all intents and purposes, more like a technical demo. I hit her so hard she went into the building. So there's 3 of them left. Their placements are actually randomized as well, so I don't actually know where they're going to spawn. Okay, there's one left. Oh, there she is. Oh, okay. Oh, I was in the wrong area. There she is. She's over here. There you go. You've saved all the world. We've got another one. Time attack. Right. I have a. This was the first city map that I was building before I switched over to doing it with Houdini and OSM data. Houdini with OSM data was definitely a great move. Then I've got my test map. This one has a lot of girls on it. It's by far one of the I think this has the most girls on it. I might be wrong. Like target girls, that's that mind you. Mm. Yeah. Anyways, so that's kind of where we're at. Now we're just trying to take this city and make it less kind of odd looking. So right now I want to actually add in some buildings and whatnot. So we're going to slowly do that. So the issue that I'm running into right now is this here requires an input. Houdini, Unreal Engine, add asset to point, or no, wait, getting started with Unreal.
In this section, we're going to create a copy to point system that we're going to be using later in.
I like his tutorials, but I want to watch them on YouTube.
Welcome to Houdini.
Might be this one.
So now we're going to set up instancing for Unreal using the system. And let me explain what this means. Right now we've copied a point, which seems what we're doing instancing, but when we look at the static mesh, the whole thing is being brought in as one big piece of geometry, which is not very efficient and could be done better. If we go to copy to points node, all we need to do is click this pack and instance button, and that will have a huge impact on how that is set up. So if we go save populate, we go back in here and we do another rebuild. Now after we rebuild it, instead of one big piece of geometry, the little cube is going to be brought in as an instance, and then it's going to get instanced within the Unreal system.
Okay. Houdini OSM create buildings as instances. What's up, Fox? Sure. This is not what I was looking for. He doesn't create, it's not instancing them this way. Actually, you know what? He might be instancing them here. OSM Houdini.
No, this is an overview of how you can. We have everything starts here on this website where we load OCM files. Then for this, then further what we can do also here is we can use the. We can do a couple of things. So first of all, what we're going to do is we're going to generate the buildings from this. So here we have a node that can generate these blockouts. Then we also have a tool in the lab tools to generate our buildings. So we can use our Midjourney models and it will generate buildings like this in this case, which is very useful. And then we repeat this process for all the buildings until we get a nice finished loop. And as a result of this loop, I'm going to use points. So like I said before, these points are then represented by instances. So each point is a point model instead of a unique 3D mesh. Then further what we can do also here is we can use the road tool. So it can generate a road for us, as you can see over here. And also the intersections here are the unique parts. And then the parts that are straight are then using a modular kit as well. So that's also possible. And further from here, from this road tool, we can use all this information that it outputs to then further create something like this. So we have a pavement and borders and so on. Then the last step here is then placing down some props, which is also being represented by points. So we can place points specifically in certain areas to calculate where props should be. Then the last step here is then placing...
It wants a point. God damn it. Houdini replace mesh with point. With instance point. Instancing replaces an object with another at runtime. This lets you, for example, use lightweight proxy geometry for a 3D display and swap to efficient, more heavyweight, detailed geometry at render time. Point instancing replaces the point of an object with other objects at render time. This makes it easy to create a large number of efficient copies. For example, scatter points. Okay, so is it actually a node? It is a node. Okay, wait. I have an idea. So if I do this, there's my box, right? And then if I come down here, this puts it in a weird spot, right? Um, yeah. Right, I don't have my transform anymore. God damn it. Okay, so minus 8.2. And this would be 8.2 to put it back, right? So then we take this and we pop that down there. We take this and we put that here. Oops. Oh, right, because it's just getting placed on top. Oh, no, there it is, right there. Oops. Look at that, it's perfect. Now this might work. Let's see if this works. This still might not work for other reasons, but we're going to try it anyways. Wait, did it rebuild? Oh, it's disappeared. Beautiful. And then if we go back to the tutorial,
Welcome to Houdini Foundation's procedural assets for Unreal. So now we're going to set an instancing, but when we look What this means. Right now we've copied to points, which seems what we're doing instancing, but when we
Oh, interesting. Okay. So it didn't instance.
look at the static mesh, the whole thing is being brought in as one big piece of geometry, which is not very efficient and could be done better. If we go to copy to points now, all we need to do is click this pack and instance button, and that will have a huge impact on how that is set up. So if we go save populate, we go back in here and we do another rebuild. Now after we rebuild it, instead of one big piece of geometry, the little cube is going to be brought in as an instance, and then it's going to get instanced within the
Houdini create point instance. Create creates. I thought that's what I did, but it didn't. Didn't work. Right, there's my instance. String attribute of instance. Houdini create instanced mesh point. Here we go. You can import instances to Houdini. You select the actor with the instance static mesh component. It's a packed primitive copied on each of the instanced points. Each material used for the instance will have corresponding attribute node. You know what? One sec. Let me try something
Points
quickly
specifically
here.
in certain areas to calculate where props should come. So combine everything together is then this result with the building, roads, and props. Hello, and in this video, I'm going to show you how you can do this through site. We're going to create a network, so geometry, and I'm going to place down the slider. And with this node, OCM node, which is called OCM. So that's city for games. Hello, in this video, we're going to create the buildings from our OCM file for each connected piece. So this means I will loop over each building individually. So in this case, I have 26 buildings. I will loop over them individually. So in here, let's just start with one building and plug this in the building generator. And you can see that by default, it will generate all this geometry. Now we also have some settings here. So first of all, like the floor height. So if I would go back here to my OCM buildings, we have set the level height to 4. So we can do this here as well. So we can set it to 4. So we have new levels. Now further, we also have here some primary and secondary options. So primary is for our main wall, secondary is for top ledge and bottom ledge. So you can enable and disable this. So now the bottom edges are gone, but we can also disable the top edges. So but in this case, I'm only using the top edge, so I actually want to enable this back. And now I want to, instead of having this plain geometry, I want to have a custom model. So therefore we need the other node called the building generator utility tools. And in here I can then have a file node for my geometry. So in here I will look up my FBX file and load in my file. So load in my file and let's plug this in. So now I need to give this a proper name. We can just call it, for example, wall 01. Then we also need to fill in the dimensions of this wall. So we can node and I have assigned different time. I'm going to size it. Now we use now use here a dissolve flatten edges. So place that node over here, and we just will increase this a little bit, and you can see that we got rid of that line over here. And if I would go back to my original OCM information, I can see that there is this line here, but we need to get rid of this line. So I will use here that line of need to use the set blast away all the modular pieces. So over here, I'm going to use a blast node, and I want to delete all the slop and the generated slop, and I want to reverse this, so delete non-selected. So this is the unique geometry that is being generated, and I want to keep this. Then I'm going to merge this as well. So merge, and I want to merge this with here the points. So you can see that we now have points, and on these points we want to assign an instance to use in Unreal, for example. Also, what we can do here is just make a group here and call this the geometry that is left over, so geo that's left over, just so I can easily afterwards can call this group. Now, other interesting information to have here is when I go back up here when I have my basic shapes, in the attribute spreadsheet, I have a attribute that's, for example, called building. So if I look for this, we have here building, and sometimes it can say it's an apartment or an office or something else. So we can use this information to then have a variation later on. So what I want to do is I want to have a promotion, so attribute promote,
Wait, what was
building, and
this?
sometimes it can say it's an apartment that from
What do I have? Because mine's largely a lot of the data is in Japanese, which causes its own unique challenges here. So if we come into here and actually we come into here, we can go to geometry sheet. This is before we've decimated anything. This is a lot of data. This does not have potentially useful information. Why is his so much better? Wait, where is his? Oh, wait, no, this was, no, sorry, it's a box already. What is, what's that ID? Building, yes. Building levels 1. Huh. Interesting. Kind of sucks that we don't have... We have a building ID, an HOU ID, which is fine, I suppose. We could work off of that, but I don't think everything has that. Yeah, everything has that. Okay. So everything has that. We can work with that. The issue then now is... We need to make our own stuff. And
that's, for example, called building. So if I look for this, we have here building, and sometimes it can say it's an apartment or an office or something else. So we can use this information to then have a variation later on. So what I want to do is I want to have a promotion, so attribute promote, and I'm going to promote that from primitive to points. So this building, and I'm going to set this to maximum, and I want to copy this attribute back into my system. So copy attribute, and instead of color, we can fill in our building. So now if I look into my spreadsheet and under points, I have now called an attribute building. So when we generate this, so now here we have information for office or apartments and so on. So this is just to show you that you can keep this information from the OCM files into our geometry over here. So you can just copy this information.
So, okay.
What can also be interesting is that we have the number of buildings. So what you could do is you can go here, create a metadata import, and then we can create an attribute. So attribute create, and I can, for example, name this building ID. And then this can be a point of a float type, and then we're just going to ask the detail value from the node I just added, which was the which is here then the for each beacon metadata. And in this node, I want to ask the number of iterations. So iteration, then 0. So I'm gonna go into this node and ask the iteration number, and I'm gonna store this in here. So let's calculate this as well. So now I have here a building ID, which we can use later on, for example, to filter out on the building number. So if I want to have building 5 to have a different look, I can then easily call building 5 and give it a different look. Now for further working with this, I'm actually going to lock the result, because every time I make a change, it wants to recalculate the system. So I'm just going to lock in the result, so we don't have to always recalculate what's going on. So now here I want to use the split net, so we can split our results. And again, I want to use the geometry left. And now I can switch between the points and the geometry, so I can make a difference for our instancing. So in this case, I want to reverse it, because I'm going to first work with the points. So which you can see here. Now from here we can use another split node, and then we can make a difference between which building it is. So what we can fill in here is we can ask the building attribute, so which I just stored here. So we can ask this building value if it's a certain type. So we can say at building, is it equal to, for example, the office? Then I want to see only the office part. So of course we also need to set this to points, and now I have only the office building. So this is then, for example, my office. We can also keep adding information, so I can copy this, and I can add, for example, the apartments as well. So apartments, and now I have included the apartments information here as well. So in here, it's just showing you that you can use these different informations to have different modular models. Now further on, we want to assign on each point a attribute called instancing. To do this, we're going to use a labs tool called a value remapping or replace. So let's plug this in over here. And by default, it's going to look at the attribute called name. So in our case, the attribute name, and here we have our model stored, the name of our model being used. So a corner, a wall, a top wall, a border, and so on. So we can look on these attributes. Now we can add these attributes by adding this plus icon, but also new here is a button for initializing values. And when you click this, it's going to automatically look at all the different values we have. And this is then very useful. So for all these models, I want to create an Unreal instance for then using an instance from Unreal. So in here, only thing I don't need an instance is actually for the slide slot, which is this generated geometry. So I'm going to click on the remove icon over here. And now I want to change the attribute from this value to another value. What is also important here, before we can do this, we also want to rename it. So we want to rename it to the Unreal instance attribute. And now here I have an Unreal instance.
Ah. Okay.
Now let's go to Unreal and grab a reference. So here in Unreal, what we'll be doing to get our reference for our instance, I'm going to go to the model that I want to have and right click and copy a reference over here. So click on this and then going back in Houdini. So in this case, I have a reference for the border, and I'm just going to copy paste the reference from Unreal. And now it's a static mesh file. If I look to my attributes now, we will now see here the static mesh names, which is then a path to the mesh there. So we will have to do this for each individual model. So we'll go back to Unreal, get the path, paste the path in here. So I'm going to skip this part. So here everything is now set up for an instance. So we all have that ready to go. Now in here I have this split, and I have also another variation. So what you can do is just copy this node, and we could start linking other models in here depending on what you want. Also here is another example. What I did here is a wrangle, and I said on the first floor I want to have a different corner model, and I changed the name attributes from the normal corner model to a corner bottom model. Also the left is then a left bottom model. So I just changed these names, and now in here I have added a new model slot for the new bottom corners that I have. So once this is set up, we can then merge these together. So this is set up, and then we have still here the geometry that is left over, and we can also merge this further down here. Now, most of the time, what I will be doing is I want to have two merge nodes, one for instances. So in here, these are all instance, and I want to have another in merge node, and this is for all geometry. So geometry. So it's important to know that you need to keep this separately, and then on the end, you're going to merge first the instance and then the geometry. This is just important to know when you're working with instances. So now I want to test this out. So we're going to select the whole thing over here, and we're going to create a digital asset. So I'm going to type a Shift-C, which will create this sublevel, and right-click, create digital asset, and give it a proper name. So now this is being saved. We now have this menu to add further parameters. So what you could expose is, for example, the file that is being used, the OCM file. But in this case, I'm not going to fill in anything. So now let's jump into Unreal and see if this is working. Now here I'm in Unreal, I have the plugin installed, and I can now just drag and drop my file, and after a moment, our city is then being calculated. And as you can see here, everything is working as it's supposed to be. So I have all my walls being set up, and I have different kind of buildings.
There we
So
go.
here I have.
Okay, so we need to add a node. Houdini add node, add point. I guess it would just be this, right? So we would go here. We'd come over here and we'd say add point. do. There's my point. And delete that. And then we want to transfer attribute transfer. And the attribute transfers house ID on primitives to point. Oops. And we come back here, we come down here. We want to source group
See that there is this line and this cloud here. I'm going to use a BLAS node for example, and I look in, and I'll set this to maximum, and I want to copy this attribute from primitive to points. So this building, and I'll set
it's wait, what did I do? I think I did a transfer attribute. Yeah, I want copy attribute. We do want to copy that, but what we want to do is we want to copy copy source to here, and this needs to be primitive. What did he drop
a
down?
variation later on.
Or maybe it was an attribute
So what I want
promote?
to do is I want to have a promotion. So attribute.
Oh, it's an attribute promote. Attribute promote.
Is promote, and I'm going to promote that from primitive to points. So this building, and I'll set this to maximum, and I want to copy this attribute back into my system. So copy attribute, and instead of color, we can fill in our building.
Copy Hey there, if you're primitive and point order match. Nope, they do not. Copy to point. Ooh, that might be it. Copy to point. This is not what I'm wanting here. Oh wait, no. Yeah, this actually might be exactly what I'm wanting. Give me a moment. Uh, there's the point, yeah. That's not copying what I want. Target points to do, we want at house. It's not copying. God damn it, what the fuck? Hmm. Oops. Geometry, value, attribute. I guess it is it is an integer. I think this is it. I keep doing that. Now ID. Gets the value of the CD attribute for primitive 7. This is what we want right here. but here we actually want this to be 1, and this would be the how ID, and we want this from 0. And then this would be I at how ID. That's not correct. Cool. Did I get it wrong? Did I spell it wrong? It is. H-O-U-I-D. H-O-U-I-D. I have an idea. Okay, so let's add a point. Houdini vex add point. Nope, I want to keep the point. Get point. Houdini vex get point. Wait. Houdini add Houdini add value to point. Ah, there we go. Oh, I was hoping they'd have like the example one. Geo handle 0. String is the name. Yeah. So it's going to be this. The point number is going to be 0. The value is going to be int. And the mode is going to be set. And of course, we don't actually get the... Of course not. Because our ID is 0, right? Because if I come into here, right, and I set this to 100. We get 100. So we're getting back the how ID here from the primitive we're getting back is 0, even though it shouldn't be. Don't care about that right now. Element. Attribute name. So this is the geometry, right? The geometry of 1, which is the input 1, right? Then the attribute name, which is HUID, right? Provided that this is actually an attribute, which I think it should be, right? Or is this a group? Yeah, okay. No, this is it. This is it. Huh. Okay. This should work on point. We also want to get the vertex color. But I think this is going to be a little bit different. I think we can do this. And I think we can do because if HUID ended up equaling 100, this would just work, right? Yeah. So as soon as I get this working, that works. CD equals vertex color from geometry 0. Sorry, geometry 1. Actually, is it point? It's point. Oh, wait. No, this is supposed to be a string. There we go. The color worked. I love it. Color. It actually transferred the color. It did not transfer the HUID, like at all. I wonder if it's because it's not a. Is it not an int? Is it a float? No, that's not it. Why you no get Hue ID? If I go like this, can I just do it from... Let's see if we can grab a different one from here. We'll go building. If I do this, and we come back up here, and it is just building. Then we come over to here and we go to point, and we don't even see it. No, there it is. 0. Oh, interesting. It's supposed to be a string, right? Houdini vex transfer attribute from point. Hmm. What if we using vex, I want to transfer a this value Nope, that still didn't work. Why can I not transfer this fucking value? I want to transfer. What if I do this? Oh, there it is. Okay. Um, it really hates that. Is this... What the... Okay, so there and color, that's what we want. And we want transfer attribute transfer. Now what we can do is we can bring that into there, this into here, go like this. And we only want to transfer point data. And we want how ID and color. There we go. Now we also want to bring that in. There. Beautiful. Then that becomes that. And then we can come back to here.
So now if I look into my spreadsheet and under points, I have now called an attribute building. So when we generate this, so now here we have information for office or apartments and so on. So this is just to show you that you can keep this information from the OCM files into our geometry over here. So you can just copy this information. What can also be interesting is that we have the number of buildings. So what you could do is you can go here, create a metadata import, and then we can create an attribute. So attribute create. And I can, for example, name this building ID. And then this can be a point of a float type. And I'm just going to ask the detail value from the node I just added, which was the...
Actually, I'm going to change the... Can we change the name? No. It's fine.
Which is here then the for each vegan metadata. And in this node, I want to ask the number of iterations. So iteration, then 0. So I'm going to
actually care.
So I'm going to go into this node and ask the iteration number, and I'm going to store this in here. So let's calculate this as well. So now I have here a building ID, which we can use later on, for example, to filter out on the building number. So if I want to have building 5 to have a different look, I can then easily call building 5 and give it a different look. Now, for further working with this, I'm actually going to lock the result, because every time I make a change, it wants to recalculate the system. So I'm just going to lock in the result, so we don't have to always recalculate what's going on. So now here I want to use the split net, so we can split our results. And again, I want to use the geometry left. And now I can switch between the points and the geometry, so I can make a difference for. Now from here we can use another split node, and then we can make a difference between which building it is. So what we can fill in here is we can ask the building attribute, so which I just stored here. So we can ask this building value if it's a certain type. So we can say at building, is it equal to, for example, the office? Then I want to see only the office part. So of course we also need to set this to points, and now I have only the office building. So this is then, for example, my office. We can also keep adding information, so I can copy this, and I can add, for example, the apartments as well. So apartments. And now I have included the apartment information here as well. So in here, just showing you that you can use these different informations to have different modular models. Now further on, we want to assign on each point a attribute called instancing. To do this, we're going to use a labs tool called a value remapping or replace. So let's plug this in over here. And by default, it's going to look at the attribute called name. So in our case, the attribute name, and here we have our model stored, the name of our model being used. So a corner, a wall, a top wall, a border, and so on. So we can look at these
Attribute
attributes.
value replace.
Now we can add these attributes by adding this plus icon, but also new here is a button for initializing values. And when you click this, it's going to automatically look at all the different values we have. And this is then very useful.
Wait, what? I don't have a how ID anymore. Wait, I thought it transferred that. Why does it keep not bringing over that ID? That ID is empty all the fucking time for some reason. It's not bringing it over. I just want to copy this over. I do not want anything else. Why does this hate me so fucking much? Wow, that number is super good. Do I have to do this one separately? What if I do this separately? What if I do only the how ID? We remove that. How ID is empty. Source group. There it is. Oh, it's so good. Okay.
So for all these models, I want to create an Unreal instance for then using a instance from Unreal. So in here, before we can do this, we also want to rename it. So we want to rename it to the Unreal instance.
Unreal instance. That's what it was.
Attribute. And now here I have an Unreal instance.
Oh, wait. That's not what we wanted. This is what we wanted.
Now let's go to Unreal and grab a reference. So here in Unreal, what we'll be doing to get our reference for our instance, I'm going to go to the model that I want to have and right click and copy a reference over here. So click on this and then going back in Houdini. So in this case, I have a reference for the border and I'm just going to copy paste the reference from Unreal. And now it says static mesh file. If I look to my attributes now, we will now see here the static mesh names, which is then a path to the mesh there. So we will have to do this for each individual model. So we'll go back to Unreal, get the path, paste the path in here. So I'm going to skip this part. So here everything is now set up for an instance. So we all have that ready to go. Now, in here, I have this split, and I have also another variation. So what you could do is just copy this node, and we could start linking other models in here, depending on what you want. Also, here is another example. What I did here is a wrangle, and I said on the first floor, I want to have a different corner model, and I changed the name attributes. And merged it here. These are all so I'm going to type a Shift-C, new to add further parameters. So what you could expose is, for example, the file that is being used, the OCM file. But in this case, I'm not going to fill in anything. So now let's jump into Unreal and see if this is working. Now here I'm in Unreal, I have the plugin installed, and I can now just drag and drop my file, and after a moment, our city is then being calculated. And as you can see here, everything is working as it's supposed to be. So I have all my walls being set up, and I have different kind of buildings. So in here I have these buildings with a different color here, and then I have these green ones. So that's pretty cool to already see working. So also here I can see different variations as well. So that already works nicely. So this was the video for generating buildings from OCM files. So from here you can then keep pushing it further, add more variations, add, for example, an interesting roof. So we have some template geometry here, but you can adjust this more to a roof shape if you want to.
Oh, let's see if that works. So I want this instance to be inside of Unreal, so I can just select it, right? So let's see if this works. This is either going to work or it's not. Oh. I did all of that stuff, and that's all I needed to do. I just didn't see it. Okay, if I do this, I wonder if this would just work. Because if this just works, this just works for me. So if I go asset, save, and then we reload. Rebuild. Oh, this is an input. Okay, so that's going to place it, but because it's an input, because it's expecting it as an input, and we've only got one here, right? It doesn't really work. Okay, so we want to go back to this. He didn't do a copy to points, but if I do a copy to points, I wonder if it would just work. Hmm. Oh wait, no, because we want the point there. Okay, there. Oh, we've blasted it away. There's the... Okay, and then we copy to the point, and it disappears. Naturally. There we go. Beautiful, beautiful, beautiful. I don't know why this split's not working. Oh, right, because it's to do... Yeah, because we want this. There we go. Instanced. Sure. Let's see if this works. There.
Unreal system instead of on how very efficient and could be done better. If we go to copy to points node, all we need to do is click this pack and instance button, and that will have a huge impact on how very efficient and could be done better. If we go to copy, we look for Unreal using the system. And let me explain what this means. Right now we've copied to points, which seems what we're doing instancing, but when we look at the static mesh, the whole thing is being brought in as one big piece of geometry, which is not very efficient and could be done better. If we go to copy to points node, all we need to do is click this pack and instance button, and that will have a huge impact on how that is set up. So if we go save populate, we go back in here and we do another rebuild. Now after we rebuild it, instead of one big piece of geometry, the whole thing is being brought in as one big piece of geometry, or Unreal using the system. And let me explain what this means. Right now now we're going to create another digital asset out of the system we just built in Houdini. So we're going to select all of the nodes in the instancing system. We're going to create digital asset. We're going to call it populate, and we're going to make sure that it's going into $hip, HDA, and we'll go into that location there and press accept. And for now, we're just going to press accept and go and see what this tool does. So in the content browser, let's go back up to the top level content where we put the building asset, and then we're going to import the populate. Drag it from the content browser over, and it'll take a second to cook, and now we see our grid inside Unreal. Now let's save and just press play to just walk around and see what that looks like. So we've got a whole bunch of shapes in here that are all randomized with their scale and orientation, and that's all as a result of the little network that was built. Now the normals are a little off on this, so we can fix that, and we can also begin to enhance what this asset does. So if we press escape, we get back to here, go back to Houdini, go into the subnetwork, and we're going to move this off to the side, and we're going to just put a normal node underneath the original shape, so that shape is working. And we're going to go save asset, populate, and if we rebuild there, you'll see that the normals are properly set up on the objects now. The thing that we want to do next, though, is we want to edit some of the properties. And just like we did before, we want to add some parameters we can play with on the assets. We're going to bring over the size, and we're going to bring over, let's say, the number of scatter points, because that's something we might want to control. We'll just call that number of instances, or number of instances. Then we can bring over the relaxed iterations, maybe maximum relaxed radius, and we bring over however many parameters you want, press accept. We go up above, we'll see those parameters there, double click in to go and look back at the network. When we now go to Unreal and we rebuild that asset, you're going to see that those parameters we just built are available for manipulation here, just like we were with the building. So we can go back to here and we can say, okay, we want to make that 8 or 10. Maybe we don't want to go in that direction. Let's go to 8 in that direction, and then we'll go in this direction. Maybe we'll go 10. That spreads those out. Maybe we don't want 250 pieces, maybe we only want 200, and we can play with relaxation on that if we want. Maybe we want to relax it a little bit less. So all that can be manipulated here, and what's happening is, again, is the host application is talking to Houdini. Houdini's clicking the node to give me the results back. So this Houdini engine allows you to have that interconnection between the two. And there we go. So that's the system right there. So now we're going to set up instancing for Unreal using the system. And let me explain what this means. Right now we've copied to points, which seems what we're doing instancing, but when we look at the static mesh, the whole thing is being brought in as one big piece of geometry, which is not very efficient and could be done better. If we go to copy to points node, all we need to do is click this pack and instance button, and that will have a huge impact on how that is set up. So if we go save populate, we go back in here and we do another rebuild. Now after we rebuild it, instead of one big piece of geometry, the little cube is going to be brought in as an instance, and then it's going to get instanced within the Unreal system. So
I've only got the one. Do I have to re-import? Yeah, I've only got this one. It's not working. Oh, you know what? It's because, is it because
this is a lot more efficient, and because of that, we can actually take advantage of it to replace the little cube with things within Houdini. So for instance, I take this bush, bring this over, and maybe change its size to, I don't know, 0.25, 0.25, and 0.25. So now we're instancing the bush instead of the little cube. So the cube in a way was just a stand-in, and once we had it in here, we were able to replace it. Now if we press the plus sign, we'll now get 2 of these. One of them has been scaled back up to 111, but we'll fix that in a second. And we're going to replace that with this rock. And by putting more than one object here, what happens is we're getting sort of a random distribution of the rocks and the bushes within the system that we built here. So it creates a nice sort of nice way to build up a little environment. Press play, and there we go. So we populated this with a combination of bushes and rocks. And you see that the sizes of the elements are still being affected by the P-scale and the orientation that we set up before. Now if we add one more element, let's go up to the level prototyping, meshes, or material meshes, and let's bring in the chamfered cube. and it just thinks about it for a bit and then it goes blue. Let's go 0.4, 0.4, and maybe just 0.2 in that direction. There we go. So now if we save and we press play, you'll see that we have 3 different kinds of objects instanced around to create this little garden of bushes and rocks and blue cubes. So there we go. Now let's go add some new features to enhance this tool. In this lesson, you're going to learn how to use geometry from the Unreal scene to drive the instancing asset. So we're going to go back into this asset and we're going to give it a maximum input of 1. And if we do that and press accept, you'll see that we're actually now there's an input that's been added to this network. And what we're going to do is we're going to create an option of either using the grid or using an output or an exterior piece of geometry. So we're going to put a switch.
Okay. So I think the... Oh, wait. I know why this is happening. This merge needs to happen further down. That's probably it. I don't need that. And here we should probably have a merge further down that's just here. And then this goes to there. There we go. And then we do... Hey, we got something. It's actually a bit of a nicer object. And we got an extra thingy here. Not what we want, but an extra thingy. It's not letting me do this. Why are you being difficult? Let's see if I can drive through it though. I think I should be able to. Yeah. Yeah. Mm. I don't. I really, really don't like the idea of doing this. But we're gonna see if this fixes it.
A maximum input of 1. And if we do that and press accept,
And we have still here the geometry that is left over, and we can also merge this further down here. Now, most of the time, what I will be doing is I want to have two, and you're going to merge first the instance and then the geometry. This is just important to know when you're working with instances. So now I want to test this out. So we're going to select the whole thing over here, and we're going to create a digital asset. So I'm going to type Shift-C, which will create this sublevel, and right-click, create digital asset, and give it a proper name. So now this is being saved. We now have this menu to add further parameters. So what you could expose is, for example, the file that is being used, the OCM file. But in this case, I'm not going to fill in anything. So now let's jump into Unreal and see if this is working. Now here I'm in Unreal, I have the plugin installed, and I can now just drag and drop my file, and after a moment, our city is then being calculated. And as you can see here, everything is working as it's supposed to be. So I have all my walls.
Why does his work? Mine does not. It's just it doesn't. It doesn't actually do the thing. And these are wrong. These why is it like this? There's supposed to be a building there. It's not under the floor or anywhere like that, right? We do this. We come back here. We take a look at this. Take a look. There's there, and then we go like this. There it is. Okay, there we go. Okay, we found the problem. Somewhere over here. I want to say that it was over here. There it is. There's my point right there. Beautiful little point. There's the instance. It's supposed to work.
File. If I look through my attributes now, we will now see here the static mesh names, which is then a path to the mesh there. So we will have to do this for each individual model. So we'll go back to Unreal, get the path, paste the path in here. So I'm going to skip this part. So here I have also another variation. So what you can do is just copy this node. So what I will be doing is I want to have two merge nodes, one for instances. So in here, these are all instance, and I want to have another in merge node, and this is for all geometry. So geometry. So it's important to know that you need to keep this separately, and then on the end, you're going to merge first the instance and then the geometry. This is just important to know when you're working with instances. So
Now it works. It's not correctly placed, but it worked. I think I can drive, I think. What the actual fuck is going on here? That was weird. I think I should be able to drive right through it. Yeah, that's what I thought. But hey, I got it in. It took a while, but I somewhat figured it out. All right, I'll be right back. Hmm. Okie dokie. I'm curious as to know if this will work. I don't think it will work. Um, I think, yeah, no, I think the answer is to fix the collisions on that specific geometry because it has no collisions. So if we go to here, hmm, for the purposes of this, let's just add a box collision for now. The real answer is just to go in and fix the collisions, right? Now it's got proper collisions. Hmm. Hmm. This should not have collision. This should not be a nav mesh in there. Can they spawn in there? They shouldn't be able to. Doesn't look like they do. This is a different sized box. There we go. Though I don't think that's right. Yeah, no, it needs to be the other side. Huh. That's not good. I have, oh no. Yes! That's not the right spot. Oh wait, no, we do. We want to keep that. Houdini add rotation to a point. Houdini add if you pack the box before Houdini. I think it's the normal, right? We want to point the normal in the right way. Right there. Okay, that's beautiful. That's perfect. Amazing. But now we need to transform this. Maybe the transform needs to happen down here, but I don't want to do it down there because I wanted to have it here for the copy to point, right? So if we do a copy to point, there's our point. One sec. This is our point. Then we pipe this into here. And this goes into here. There we go. Okay, so now what we need to do is, it's not this, we want normals, right? Wait. We do want this because this has the value, right? 0, 182, 188. Okay, so it would be 0, 188.20. Hmm. We do this. Where the fuck did it go? There it is. It just disappears. Oh, there it is. That's in a really weird spot. Why is it over there? It's supposed to be matching size for this. Yeah, and then we move it over there. There, okay. Yeah, okay. Wait. And then we want that. There we go. Okay. If we use copy to point, can we get this oriented correctly? And the answer is most definitely yes, if we keep at it. But I don't know fucking what to do here. It does seem like this though. But the normals are not copying correctly. Copy to points with normal rotation. Houdini. Like copy stops.
Hello and welcome back. This is Rise Blacks. You are watching episode 3 of Getting Started with Houdini. And in this section, I wanted to talk about making copies, orienting the copies, because possibly you have already tried to make copies and distribute them in some sort of arrangement, but maybe you have run into some problems. So let's discuss just that. Again, as per usual, I'll start with the tab, start typing geometry. Whoa, what is going on? Okay, start typing geometry, enter, enter. Okay, now the first thing I want you to do, and what we will do, is create a circle. So this circle represents basically the like copies, copy stamping. Define that will be done to our geometry, right? Maybe it will get rotated as well as it gets copied, like let's say like that. We define the number of copies, and as you can see, we indeed do have one way of copies start to behave differently just because copying evaluates everything. Will be copying our geometry onto points. Now it comes with huge advantages and with a caveat. We have our circle. I'll just make. And next up, I mean, depends on what's your goal here, but to me personally, it's a bit too much. So I'll disable the maximum segment length and instead enable the maximum segments. And as you can see, it immediately starts. Well, what we want it to do, right? It starts to resemble the segment, the ideal representation of a circle into the polygonal, which is a bit more faceted, but it will be very useful for our copies. Now, next up, I'll tap the copy to points. And as per usual, the geometry is on the left, the targeted point is on the right. So we actually make kind of clean this up a little bit. And if we now look at our copy to points, and I'll disable the points, we can see that our boxes are oriented, well, basically the same way. And it's not exactly sometimes preferable way of, orienting our geometry onto the copies. In our case, I want them to look to the center of our circle that they create. So to do that, we have to go and make the polyframe and drop it after the resample. Now, nothing will change, but let's dive inside the polyframe and see what it actually does. Now, as you can see, before we made a polyframe, we can inspect our node and our geometry by clicking the eye icon, or just by hold down middle mouse button on the node. So you can see that there is one point attribute, that is P, which stands for position. And when we have the polyframe, there are 3 point attributes: normal, tangent U, and P as for position. Now, if we look in our example and we enable the show, so it shows our normals, the point normals, they are facing down, and the normal of the primitives, basically it faces down as well. Now, this is happening because it's reversed once more, but you kind of see what's happening, right? They are just facing down. And when polyframe is enabled, we now have new normals that are blue, because they now have the blue, and they are for primitives. Now, the thing is, it computes the normals by the actual normal. Now, normal is the direction that the face or vertex or point is looking at. But what we want to do is have our normals. And by the way, when you copy to points, the copies get oriented how the normals were oriented. Now, if we want them to look inside our circle, the copied boxes look inside our circle, we need to write normals as if they were tangents. So I will disable the normal name n, and instead write n, which stands for a normal attribute in Houdini, in the tangent. And if I now press enter, voila, our copies are oriented as we wanted them to be. So there you go. You can compute the tangent and write them as the normal. This is important in Houdini, the very fact that you can operate any attribute you want and write that or overwrite any attribute that you need, or create it at your own leisure.
Houdini. Yeah, I want to transform. This is cool, but it doesn't teach me the part that I care about.
I think we will talk a bit about this more when we will be tackling the problem of attributes in the subsection, or maybe in another workshop. I think I'll create another workshop just for attributes and attribute swaps. But for now, you just want to know that the polyframe creates the tangent, and you can write it as normal. Now, this is kind of interesting. Why? Because we can now make a number of copies that we want based on the number of segments that we have. This is not just for a circle. We can create a line and do the same thing. Copy it here, and now we have a line. Actually, I want it to transform first. So let's see length a bit more. I'll enable the showcase of the points. Let's say we have like 4 points, and now as you can see, we have 4 copies of our box. Now we just rotate it. I think we should rotate it in the X. Yep. So we rotate it at 90 degrees. We now have a perfect the perfect lineup of our boxes. Okay, this is fine. Now, why would we want to do this with the line? Because now we can operate with the line as how we want. So if I select, press S, press 2, select this, and press T to move it around. As you can see, now if I resample, like here, actually let's make it NURBS. So again, what I did is I made it as a NURBS. So it's and have our boxes copied. Again, if we do the polyframe, where is it? Polyframe, again, writes normals as normals, tangents as normals, I'm sorry. We have our boxes oriented pretty much perfectly. And just for the sake of the illustration, I drop the transform node, scale it a bit down, and there you go. So now, what's interesting about this setup, I'll make the length a bit longer so it kind of illustrates my point a bit better. Now, if I start moving these points around, it automatically makes the recompute of the orientation of the boxes.
It's not what I was looking for. What's up, Lucifer?
Hi all, today will show you the quick tip how to rotate normals. For that I will use the simple grid. Add some normals. Delete the faces. And here we need to select the points. Now we have normals. For that I will use test geometry with this man. Rotate it 90 degrees to the z-axis. Transform it. Okay, I will use here better. Copy to 2 points. Here our geometry is copied to the points. Scale it down. And now we use the transform SOP. And in attributes we choose the normals. And now we can use the rotate them.
Oh, that's how we do it.
Here better. Copy to 2 points. Here our geometry is copied to the points. Scale it down. Add some normals. Delete the faces. And here we need to select the points.
There we go. I think this should work now.
Now we have normals. For that I will use test geometry with this man. Transform it 2 points. Here our geometry is copied to the points. Scale it down. And now we use the transform SOP. And in attributes, we choose the normals. And now we can use the rotate them.
That's just not working. Why are you not transferring? Why are you not rotating the way that I want you to?
No X, no ops. Simple way to rotate normals. Thank you for watching.
What if I add the transform down here? This is probably one of the worst ways to do it, but like, what if I add the transform here? Would a transform here work? No, the transform just does not work anywhere, apparently. Oh, that's why. I'm getting zeros. Here's my point normals. It's beautiful. Just not at all. I love it. That's a little bit better. I think my normal got moved. No, that is the right normal. There's my normal.
Hello everyone, and welcome back to the eHoudini Academy Foundation module. In this video, we are going to cover how to start working with instances in Unreal. Mainly, how we can bring some of the event objects that we have in our meshes folder over here, and instantiate them onto our building using Houdini's instancing system. The main reason that in Unreal you want to use instances is because they are very fast and lightweight. It's not just that we are simply copying static meshes onto our roof, which we will be able to do with this tool if we use the split instances mode down here. But the split instances mode basically generates meshes for every single object. We can actually select them right now as individual components of our building and move them around. However, if you have a very large amount of copies of these meshes, this is very heavy. So if we use a standard instancer, on the other hand, then you can see how we now have an instanced static mesh component over here. And these basically combine every single mesh that is unique. Into one static mesh instancer, and this will allow us to optimize how these meshes are loaded, because only one mesh in this case is loaded. So every single mesh here on the building, that is a small vent for example, is basically a copy of a single mesh in memory, and that's a lot more efficient and a lot faster for Unreal to deal with. Now you might see that there are a couple of changes to the tool since we last finished the last video, and that's simply because I upgraded the toolset a little bit to support a couple of extra features that I want to cover, because I think they're very interesting. First, in this video, we are going to cover Unreal instances and Unreal Split instances. And these basically allow us to take these meshes from our meshes folder and instantiate them onto our building, like I mentioned. But then in the next videos, we are also going to cover the basics of creating meshes from FBX files and then copying them with full textures and full collision. And you can see that right now, it looks like nothing has changed. But at this point, this building is no longer placing these meshes. Instead, it is taking the FBX files from my hard drive, and it is simply recreating them on the mesh, complete with materials, which I can show you if I disable materials, and also various types of collision meshes as well. And these will still work. I can still go ahead and play, and I will be able to collide and jump on these objects. And there are various types of collisions that we will cover in these videos. And you can also see that there are a couple of extra visualizers involved, and we will cover this in the upcoming videos as well. But for now, let's have a quick look at what these instances can actually do. So let's switch the tool back to its basic instancing mode. And the first thing you'll notice is that we have these dots all over our roof. Now these dots indicate where instances can and cannot spawn. And I've visualized this using the visualizer so that we can see that we have the vents that are spawning, but then we also have the red dots, which indicate that in this case, the small vents are unable to spawn in these locations. And this is mainly because of our vent spacing, but also because of the size of these vents. And this is done in order to prevent the vents from actually blocking the player, so that the player will always be able to navigate the roof. If I go ahead and click play, and I try to walk between my vents, then in most cases, you'll be able to see that the player can actually navigate between the vents, the edge of the building, and also the rooftop elements, such as the staircase and the elevators. Now we can control these objects over here. For example, if I change the amount of vents to, say, 25, then it will now populate every single spawn point. We also have control over how many large vents and small vents we actually want. So if I set this to 0, I will prioritize large vents over small vents exclusively. So we will only have those. On the other hand, if I set it to 1, then we will only have small vents on the roof. And if you change the value to anything in between, you will get a mixture between either small vents or large vents. We also have a seed value, so we can change the actual layout and rotation of these objects, and they will rotate in 4 different orientations. And finally, if we change our vent spacing to something smaller, which will prevent the player from actually passing between them, but you can see that now we can actually place a lot more objects on the roof. If I populate the entire roof with objects by, say, increasing the vent count to 100, then you can see that we can populate the roof, but they will, in general, as long as you don't place them too close to one another, prevent themselves from intersecting with one another. Of course, at this point, it's going to be very hard to navigate our roof, and I don't think any building ever will need this many ventilation objects, but, well, that's beside the point. Okay, so let's return this back to some of our default settings. So let's go over to Houdini, and let's have a look at the new example file, version 1.1. So you can see that I have made a couple of changes in between this video and the last. Down here, I have split up the FBX loading system, and I basically put it in its own output. So we have a dedicated output for the meshes that we can generate for the roof. We'll cover this in the next video. And then over here, this is what we'll be building today, this section right here. So the first part we'll be working on is the pillars inside of our building. Let me just hide everything else. And you can see that we do have pillars inside the building, but they are going to make sure to avoid the obstacles inside our structure, such as the elevators and the staircase shafts. And to make sure that they don't get too close to these objects, we are going to use the delete by distance node once again. Next, over here, we're going to cover a couple of different methods on how to build a spawning grid for our points. This will allow us to create points inside of our structure, and then we're going to call those out, so we only keep a series of valid spawn points. Now we do need to make sure that we can also establish a ratio between our large vents and our small vents, so that's what this section here is going to deal with. Down below, we have the instance data assignment. This is a hard-coded database because I only have 2 meshes to instance here. If you want to build a more advanced database, you would basically replace this with a more dynamic system that would load it from, for example, an external file. But right now we don't need that, so we are going to set up a basic setup using a Wrangle node that will assign a couple of variables to our points, a couple of attributes that we'll need for our instancing to work. Then we're going to copy these points onto our spawn points so we can assign them. And then finally, down here, we're going to send this out to a dedicated instancer on the outside of our geometry, right there, which Unreal will pick up, and then it will allow us to spawn our instances. So now we've basically covered all of this. Let's go over to our main project and let's get started on that. Alright, so let's get started. The first thing I would like to work on is the pillars on the inside. So down here.
This is so much for the only thing that I care about right now is Houdini Unreal Engine instances. The output by using packed primitives, object instancers, or attribute instancers. This can be specified using the Unreal instance attribute in the non instances can also be created using the instance object node. In previous versions of Houdini Engine, object instancer was the only way to output instances. However, since support for packed primitives was added, using them is a recommended way to output instances. The recommended way to create instances via the plugin is by using packed primitives. A simple way to use this method is to use copy to point SOPs with the pack. Okay, so if I go back into Houdini here, there, and we come up to here and we just do this instead. Will this work? Oh, this isn't even right. There we go. This will pack primitive instancer you can use. Instance geometries are represented in I wonder if it's because there's only one point that's that's there, and if there was more than one point, if it would work.
You'll see that go in this lesson. You're going to give it a amount, and what we're going to do in between here, and we're going to, and if we do that and press accept, so now we're going to set up instancing. Do is click this pack an instance button, and that will have a huge impact on how that is set up. So if we go save populate, we go back in here and we do another rebuild. Now after we rebuild it, instead of one big
Okay, so we have this. Oh, there we go. They just changed how it is. Yay! Yay, it worked! We got it! We got him, boys! I wonder if it will keep the vertex stuff. Right, because we're not transferring the vertex colors. Do 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 do. I do not like that this is not a parameter that I can choose. Actually, is it now a parameter that I can choose? That's not annoying at all. Because then I have to go to here, refine proxy, right? And then we come to here. There it is. And then we have to come to here, and then we have to do SM undergrounds there, and it doesn't transfer. That does blow. But oh well. Yeah, no, that fucking sucks. I'll be right back. Mhm. Mm. I don't like this. With packed primitive instancer, you can use the Unreal split instances attribute to create separate static mesh components instead of the instanced one. The Unreal instance color primitive attribute can then be used to specify an override vertex color to apply to the packed primitives. Is this it? There was something that I wanted back here. Is it the attribute copy? That's the color. All right, right. Oops. Maybe this? Let's try this. Nope. Okay, what was the thing here? Packed primitives is what we want. No, that wasn't it. God damn it. Uh, cast combine. Is it a copy? No. Copy, compose, combine. Attribute of rename. I think it was this. Uh, we should also do static geometry. Besides instancing geometry generated by an HEA, instances can also be created for pre-existing. This can be done using Unreal Instance attribute and setting the attribute value to assets reference. You are limited to static meshes, but the instanced asset must be convertible to a native actor type. In this case, multiple instances of this actor can be created. I wonder if it's this that I want. I'm not getting this. What the fuck? Level instance is supported. Unreal expects both the source and target level to have certain settings enabled, such as external actors. We therefore suggest running map check in Unreal when developing your HDA, an instant pipeline to ensure your data is compatible with the latest version of Unreal. I absolutely hate this, but it might work. Actually, wait. I don't care about that. That's Lucifer. He's a friend of mine, and that's just yeah. He's like that. It's the only thing he ever says. By the way, this is the whole thing that I created yesterday. Oh, I totally forgot to do something. Yeah, I don't actually need this. Delete edges. Whatever, it doesn't matter. No. No. It's entrance to the underground. Underground station entrance. It is Pacifically. Actually, I think I've got one here. It's this. Specifically this. Let's see. If we come over here, you can kind of, oops. Actually, it's probably easiest to see from over here. Yeah. And now I'm trying to get it to place it inside of here. Like I'm trying to place it right there. And right now this here object is that one. Right? So this is this. But I want to be able to define this. And it's being difficult. No. No. I'm not using the terrain system at all. Like, let me try this instead. It's missing now. And it just doesn't exist. Okay, beautiful. This is not showing up. Why is this not showing up? Please, for the love of God, I added you in and you refuse to show up. Let's see if that works. Maybe it wanted a specific name. No. Uh, I'll kind of show you what I'm trying to do right now. So here, right, you've got these.
Big piece of geometry, the little cube is going to be brought in as an instance, and then it's going to get instanced within the Unreal system. So this is a lot more efficient, and because of that, we can actually take advantage of it to replace the little cube with things within Houdini. So for instance, I take this prop bush rather, bring this over, and maybe change its size to, I don't know, 0.25, 0.25, and 0.25. So now we're instancing the bush instead of the little cube. So the cube in a way was just a stand-in, and once we had it in here, we were able to replace it. Now if we press the plus sign, we'll now get two of these. One of them has been scaled back up to 111, but we'll fix that in a second. And we're going to replace that with this rock. And by putting more than one object here, what happens is we're getting sort of a random distribution of the rocks and the bushes within the system that we built here. So it creates a nice sort of, nice way to build up a little environment. Press play, and there we go. So we populated this with a combination of bushes and rocks.
Yeah, so we got that, right? And I'm trying to utilize Houdini to recreate that. So if I come down here and go like this, show you the entirety of the map, right? There's the roads and everything like that, and the roads are all splines. So like if I come in here, we can actually see the roads here, right? So I can just rearrange them, and then they just generate the roads and the intersections and the geometry for the intersections and all of that. And there's points that I can if I come over here, I can do null, right? There. right? And then we have, oops, that's not what I wanted. This is what I wanted there. We've got points for that. And also change here. Here are the points for the splines themselves. And then if I wanted to, I could like, I could expand them out, right? And then place down things, right? Like I could be like, oh, hey, you know, we want to add X or Y instance, right? And there's a bunch of stuff we can do there. But for some reason, it's not allowing me to do this the way I want to.
Now I want to test this out. So the remote kind of buildings. So in here I have these buildings with a different color here, and
Maybe this
video
one
we're going to
has
create a
it.
road system for so primitive. Then let's just, you can already see it's going back to 0. So let's say this is 1, and let's say the width here instead of 1 is, for example, 0.5. And you can see that these are then smaller than the other ones. So I can have a size variation, which goes here. And then we also have 3 different outputs here. So the first output is what you see, is this geometry. The second output are just our lines. So if I would click on
Oh,
numbers,
I'm an
we
idiot.
can then have the outer lines, which can be very useful later on. And then the last input is a point cloud for our instancing. So if you want to do instancing, we can do this as well. So let's focus more on getting this properly in Game Engine. I want to extrude this of the information that I have. So this can also be great to have enabled. What you can also do here is play around with the pattern 15 by 15. So when I would do a quick shade situation, so in this case I notice that my information is quite great. Key information is not a transform, and so this is, and see what it gives us in Unreal. And this is what I'm having now in Unreal Engine. So I can see that most of it is working, except here for my main road. Click copy reference and use this in Houdini. So this is set up, and also something interesting here, we need to set up the scale as well. So all of our other instances over here, they have a scale value. So if we were not to have a scale value over here, that might conflict when opening it in Unreal. So we're going to set here scale, and scale is 3 in size, and just put it in 1, 1, 1. Now it's also possible to have a, for example, a attribute random, and then have a random scale. So just going to, for example, fill in scale over here, and then
So it really wants us to have this as, okay. So essentially we have to have this as a, fuck, this blows. Attribute create. Attribute create here. String, we want this to be, I guess this might be the new way of doing it. I don't like it at all. Right, we do that, and then we go here and asset, save. We go into here and we rebuild. My point's not there anymore. Okay, so if I do that and then this, my point is not there, and that is a problem. Oh, that's why. This is my point right here. There. Okay, there's my point. There's my pointy point. Okay, there we go. Asset. And then, right, it was just Unreal Instancer. should put it this time. Of course, now it doesn't. No, it's really broken now. It's like super duper broken. My point is there. Is the normal not the normal should be attached. The normal's attached there. It's attached there. There. Output. Does that not have a normal? I don't think it has a normal anymore. Either that or no, it's just not getting created at all because I'm not seeing it here. Did I get the... There we go. The attribute name I got wrong. There we go. Love it. 10 out of 10. Hmm. There we go. Now I just want to make sure that it will rebuild. There we go. So it places it down. It's not exactly what I want though. Anyway, so now if we come over here, right, I can then do this. We're going to leave that for now. Oh. So So essentially what we have is if we look at this, right? This is all of our buildings. And look at the here. Now each building has a HOUID. And we're going to utilize these to actually, this might even be better. Yeah. So if I go like this, there. Then we then all we want to do is we want to take these primitives and we want to add a point to the center of each one. Okay, so we have all of them, and then we want to add a point with normals and our attribute wrangle. Our attribute wrangle is going to be the insane part of this, because we need to match what would be like the forward vector and stuff like that. Ugh, it's going to be a pain in the ass. What do you mean missing template geometry? The geometry is right there. Oh, it's not anymore. Okay, sweet. So now if I go into here and I do asset, save, and then I come into here and I come down here and rebuild. We get all the terrible stuff. I really screwed that up. It's like a whole new level of fuck up. The colors aren't there anymore. There we go. Now the colors will stay. Yeah, okay. Fucking rights. Okay. Look at that. Now if I hit play. If I save. There we go. And now if I hit play. Look at that. It placed them all. They're not oriented correctly, but it placed them all. So the kind of pain in the butt part is that now I've got to go in and try and figure out how I'm going to place each and every single one of these in a way that doesn't cause my head to explode out of sheer anger. But I'll deal with that later. For now, what we want to do is just not deal with that. So essentially, like what we really need to do is come down here, and if I look at this, right, what we want to do is add a forward vector to this to detect the direction it needs to be in. But then the question is, where does the forward, like, what does it point towards, right? And the answer ends up being, I have no fucking idea. Because if I throw down a null right here, we can actually take a look at all the data that we have on this in this geometry spreadsheet here. And we don't really have much info. So we'd have to like craft a giant if block to be like, where does it go? Right? Where's the entrance? And the answer is, I have no fucking idea where the entrance is. So I'm gonna need two wrangles, a point wrangle and a point wrangle and whatnot, and then I'm gonna have to like grab from from different stuff, but I'm going to take this opportunity, though, to call it for now. Yeah, I'm going to call it for now, and I will be back later. I'm going to go eat. All right, well, thank you to everybody who showed up. It was great to see you. And ta-ta for now.